Beneath the surface of United States farmland lies a massive reservoir of organic matter. It is the largest terrestrial carbon sink in the country, currently holding roughly 20 billion tons of organic carbon. This map tracks the potential impact of carbon sequestration. Increasing the soil carbon content by a single % nationwide would remove 1.2 billion tons of carbon dioxide equivalent from the atmosphere. That volume of tracked carbon represents a significant revenue stream. Farmers can monetize this through private carbon credit markets or access portions of the billions in government funding allocated for climate-smart conservation. Yet the vast majority of farmers cannot access these financial opportunities. Participation in these markets requires proof of exactly how much carbon is already in the soil, a baseline most farmers cannot easily establish. The data required to establish those baselines already exists. It has been measured, cataloged, and publicly housed by government agencies like the USDA for decades, but retrieving it involves an immense physical barrier. Acquiring field data often defaults to manual soil sampling, a process that forces a farmer to wait up to 12 weeks for lab results, while paying between $500 and $2,000 per field. This interface demonstrates the digital alternative. The USDA's digital soil database exists, but extracting a single metric from it requires highly specialized geographic information system software and the GIS expertise to run it. The United States possesses the greatest agricultural database in the world, yet for the everyday farmer making daily decisions, that intelligence is functionally trapped behind a paywall of consulting fees and technical bureaucracy. LeafEngines approaches this problem from a different angle. However, extracting the data is only half the battle. Government databases return highly technical codes, like specific bulk density figures or obscure drainage classes, that provide little immediate value to a grower. This diagram illustrates the translation mechanism. LeafEngines routes these dense scientific data blocks directly through an AI gateway powered by large language models. The AI processes the metrics and translates them into plain English. It delivers actionable advice regarding crop suitability, environmental risks, and carbon potential straight back to the user's phone. By combining precise database extraction with natural language translation, the system addresses the last-mile problem of data delivery, turning an impenetrable database into a 3-second text message. Because LeafEngines is built as an API, a back-end interface rather than a standalone app, it never forces users to learn a new piece of technology. A farmer checks soil viability via Telegram in the tractor cab, while an agronomist sitting in an office pulls deep environmental analysis directly through desktop AI assistants like Claude. This diagram maps out the enterprise scale. A climate fund manager can plug this core API directly into workflow automation software, allowing them to instantly run carbon baseline queries across thousands of individual counties simultaneously. True technological accessibility is not about building another complex dashboard. It is about delivering critical intelligence invisibly into the exact workflows that agricultural professionals already use every day. We can measure the impact of this platform by looking closely at the economics of farm data before and after automation. Gaining the soil baselines required for a carbon project historically meant hiring a specialized consultant, paying upwards of $2,000 per field, and waiting up to 3 months for the final report. This split-screen graphic compares that old model to the new reality. Obtaining the exact same authoritative data now requires $0, no specialized mapping software, and exactly 3 seconds. By combining open data with AI translation, the marginal cost of actionable agricultural intelligence has dropped to fractions of a penny. By functioning as a search engine for farm data, LeafEngines acts as an economic equalizer. It turns the climate and financial potential of agriculture into a reality by making public knowledge truly accessible to the public.